Okay, so this video is going to cover completing the square, some additional information beyond what I did in class. So, the idea here is we're going to start with a quadratic in standard form. That's what this one is, right? This is the standard form. Okay. And we want to change it into vertex form. And something is wrong with my pen. Hopefully it's just on this page. Alright, so let's look at the principle behind this before we do anything else. All right. The idea here is you want to be able to recognize a perfect square quadratic, alright, which is this. And again, for those of you who don't know how I get from step 1 here to step 2 here, you just do it by multiplying. Alright, so all I'm going to do is multiply, right, do this FOIL multiplication here, and multiply this out. So I get x times x, x squared, plus p times x, plus p times x, plus p times p, so p squared. Alright, and then combine the two terms in the middle, and you got px plus px, well that's 2px plus p squared. Alright, so the key here is that the p here and the p here are the same p. If you can find what p is, then you know what p squared is. So what I have here is a perfect square quadratic. Okay, I know if this is a perfect square quadratic, then this 6 here has to match up with that 2p there. So that means that my 2p has to equal 6. Alright, so 2 times what is 6? Well, I can get that by dividing if I need to. And p is 3. Alright, so I can now verify what is p squared is 9. Alright, there's definitely something wrong with my pen. P squared is 9, alright, which is what I have here. So now if I want to find the factored form of this, it's going to be x plus p, which is 3. Alright, that's the basic principle. Let's look and see how we're going to use it to change this quadratic into vertex form. Alright, so there's a series of steps you need to go through. The first step you need to look for is if you've got a leading coefficient here. The first couple of examples I do, I'm not going to have one. Alright, so this example doesn't have one. So the next thing you want to do is take your constant term, and we want to move it over to the other side. Alright, so over here I'm going to have y minus 7 equals x squared plus 8x. Now I want to turn this right side into a perfect square. So if this is going to be a perfect square, that means the coefficient of x is 2p. So I'm going to come over to the side here and say 2p equals 8. So I solve this, and I get p equals 4. Right? So to make this a perfect square, I have to add p squared to this side. And if I do it to this side, I have to do it to this side. So that means I'm going to get y minus 7 plus, what is p squared? Well, let me write that down here too. P squared is 4 squared, which is 16. So I'm going to add 16 on this side. And I'm going to add 16 on that side. Okay. This side I can just do the arithmetic, right? This is going to be y minus 9. And on the right, I now have a perfect square which is x minus p. So x minus p, which is 4. Alright, so that is factored. So now the only other thing I have to do with this one is bring the 9 back on the other side. So I need to add it back over here because I subtracted it in the first place. So now I have y equals x minus 4 squared plus 9. And then I can read the vertex off, right? 4 comma 9. Alright, let's look at another one. Now, this one has a leading coefficient. Alright, so the first thing I need to do is divide that out. I've got to get rid of it because I can't do this process with it there. So I'm going to take every single term and I'm going to divide it by 2. Everything gets divided by 2. Alright, so on this side now, well, y over 2 is just y over 2. There is nothing I can do with that. Right, on this side now, 2 over 2 is 1, so that is just x squared, plus 20 over 2 is 10. It's 10x, plus 16 over 2 is 8. Okay? Alright, so now I'm ready to do my second step. I need to get rid of that 8. So I'm going to bring the 8 over to this side. Alright, so I've got y over 2 minus 8. And on this side I've got x squared plus 10x. Alright, now I want the right side to be a perfect square, quadratic. So that means my 10 corresponds to 2p. So that means my 2p has to equal 10. Divide both sides by 2. And p equals 5. So that means p squared equals 25, right? 5 times 5. So 25 is what I have to add to both sides. So I get y over 2 minus 8 plus 25 equals x squared plus 10x plus 25. All right. So now again, on the right side, this is now a perfect square quadratic. And it's going to be x minus p, which is 5 squared. On this side, minus 8 plus 25 is going to be 17. Alright, so now I have 2 steps left. I need some room up here too, because alright, I have 2 steps left. The first thing I need to do is bring the 17 over. Alright, I'm going to move this up here now. So on this side, I'm left with y over 2. On this side, I've got x minus 5 squared minus 17. And then I need y by itself, so I have to now multiply by 2, right? At the beginning, I had to divide by 2 to get it over here, so to move it back, I have to multiply. So I multiply this whole thing by 2. So I get y on that side. I get 2 times this. And I get 2 times this. And that is my vertex form. So now again, I can read my vertex off. 5 comma negative 34. Okay. All right, one more. All right. Again, I have a leading coefficient, so I have to divide it out. I'm going to kind of move over here a bit so I have more room. When I divide every term by 3, alright, so I get y over 3 equals 3 over 3 is 1. That's what I want there. 9 over 3 is 3. And 15 over 3 is 5. I bring the 5 over to the other side. Alright, so I get y over 3 minus 5 equals x squared plus 3x, okay, and then that's 0. Alright, now again, I want this to be a perfect square quadratic. So that means my 3 is my 2p. So I'm going to come over here and say 2p equals 3. Divide both sides by 2. And p equals 3 halves. Right, so that means p squared equals square 3 halves. We get 9 over 4. Alright, so 9 over 4 is what I have to add to both sides. So y over 3 minus 5 plus 9 over 4 equals x squared plus 3x plus 9 over 4. Alright. Now I have to combine these two. So think about adding fractions. I need a denominator of 4. So that means I need to multiply by 4 here. And I need to multiply by 4 there. So that's going to be 20 on the top. So 20 over 4. So minus 20 over 4 plus 9 over 4. So minus 20 plus 9 is minus 11. So we've got y over 3 minus 11 over 4. This is now a perfect square. Factors into x minus p. So x minus 3 halves squared. Alright, so now I just have to bring everything back onto the right. So add 11 fourths. Right, and again, I'm going to bring it up here. So on the left, you'll have y over 3 equals, let's see, x minus 3 halves squared plus 11 over 4. And then I have to divide by 3 in the first step, so that means I have to multiply by 3 in the last step. And so I get y 3 times this plus 3 times 3 fourths, so that's going to be 33 fourths. Alright, so now I'm in my vertex form. I can read off my vertex. So that's going to be 3 halves, comma, 33 over 4. And I think I need to change the battery in my pen. Alright, so just in summary, alright, the method you're going to use, you want to divide the leading coefficient from both sides, if there is one. You want to move the constant term from the left to the left side. Set the coefficient of x equal to 2p and solve for p. Alright, then square p, so you have it, right? Add p squared to both sides. Factor the right side into x minus p squared, and return the constant and the leading coefficient to the right side of the equation. All right, so you're just going to follow those steps and you'll be able to complete the square.